The Arctic tundra, a vast frozen landscape known for its icy stillness, has played a crucial role in balancing our planet's carbon cycle for thousands of years. But something alarming is happening. For the first time in millennia, this region is releasing more carbon than it's absorbing. To understand what's changing, we first need to know how the Arctic tundra works as a carbon storehouse. In most ecosystems, plants absorb carbon dioxide, CO2, from the atmosphere during photosynthesis. When these plants, or the animals that eat them, die, their remains decompose, releasing CO2 back into the atmosphere, completing the carbon cycle. But in the Arctic tundra, things are different. Here, the cold climate slows down decomposition drastically. Plant and animal remains are trapped in frozen soil called permafrost, ground that stays frozen for at least 2 consecutive years. This permafrost acts like a giant freezer, locking away carbon for thousands of years. In fact, Arctic soils store over 1.6 trillion metric tons of carbon, twice the amount of carbon currently in the atmosphere. But now, this frozen vault is thawing. According to the National Oceanic and Atmospheric Administration's NOAA Arctic Report Card, the Arctic tundra is no longer storing carbon as it used to. Instead, it's becoming a source of greenhouse gases like CO2 and methane, CH4. So, what's changed? 2 main reasons are behind this shift. 1. Rising temperatures. The Arctic is warming nearly 4 times faster than the global average. In 2024, the region recorded the second warmest annual surface air temperatures since 1900. This intense warming is thawing the permafrost. When this happens, the frozen organic matter inside the permafrost becomes accessible to microbes. These microbes break it down, releasing CO2 and CH4 into the atmosphere. Twila Moon, lead editor of the Arctic Report Card, explained it well. Think of permafrost like chicken in your freezer. As long as it stays frozen, it's fine. But once it thaws, microbes break it down, causing it to rot. The permafrost is doing the same thing. 2. Increasing wildfires. Wildfires in the Arctic have become more frequent and intense in recent years. In 2023, the region experienced its worst wildfire season ever, and 2024 wasn't far behind. Between 2001 and 2020, rising temperatures and wildfires combined to make the Arctic tundra release more carbon than its plants could absorb. This likely hasn't happened in thousands of years. This shift has global consequences. The Arctic tundra's emissions will add to the greenhouse gases already causing climate change, exacerbating extreme weather, sea level rise, and other impacts worldwide. The Arctic tundra's fate depends on our actions. The NOAA report emphasizes that reducing global greenhouse gas emissions is the only way to flip the Arctic back into a carbon absorber. Lower emissions mean less warming, which could slow down permafrost thawing. Brendan Rogers, a scientist who contributed to the report, puts it simply: with lower levels of climate change, you get lower emissions from permafrost. But unfortunately, global emissions are still rising. According to the Global Carbon Project, total CO2 emissions are projected to reach 41.6 billion tons in 2024, up from 40.6 billion tons last year. The Arctic tundra's story is a stark reminder of how interconnected our planet is. By reducing our emissions, transitioning to renewable energy, and protecting ecosystems, we can help preserve this vital region and mitigate the worst impacts of climate change. What happens next is up to us. Together, we can act to protect the Arctic tundra and our planet. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe